Back. Photoelectric effect. See the photoelectric effect which we were discussed for different metals. For different metals, different light is required to emit out the electrons with the suitable amount of frequency. Other than alkali metals, visible light is not able to emit the electrons. And you can also see here how experimental setup for the photoelectric effect. Experimental setup for the photoelectric effect. Okay. So I need to see both. That also live I need to see. Tell me from there what I have to do. Yeah. Now you can see here. This is an evacuated glass tube. This is an evacuated glass tube with photoelectric effect. In this this is a quartz window. Through this quartz window, I am allowing the light to fall. Right? Remember everyone, this is the most important. Be active and listen. Okay? So through this quartz window, I am allowing the light to fall on a metal plate. Here two metal plates I am using. One I am taking as a cathode, other one is anode. How it could behave as an anode and cathode? I am connecting to the external circuit. Therefore, here I am connecting. This is as a negative terminal. This is as a positive terminal. Right? Means I am creating the potential difference between these two negative and positive terminals. You can see very clearly the circuit. This is the most important one. From this experiment, there are the experimental effects here. There are the experimental effects which are called as graphs. The graphs are most important here. Okay. First, you need to understand the graphs. In the sense, you should understand this concept. What is exactly the photoelectric effect? We know that when through this positive window, when certain amount of light falls on here, how it behaves as a cathode. When the switch is on, this is connected to negative terminal, this is connected to the positive terminal, and are connected to the microammeter. Means it is a small amount of current which develops here, right? So whatever the small amount of current which is developing here, that gives us output for this effect. That is we call as photocurrent. Got it? Photocurrent. Now, how the photoelectric effect takes place? See here. This is the UV light. Okay. This is the UV light. UV light source I am using. From the UV light source, the suitable amount of light whenever it is incident, after incidentally a metallic plate of cathode, which is having the negative potential. Remember, okay, negative potential only emit out the electron since it is having the more negative charges. So the suitable frequency of light is incident, then therefore it moves towards the anode. What anode will do? Since anode is a positive terminal, it is having the positive potential, automatically it attracts the electrons, right? Therefore, towards the anode electrons will move. This is very clear. When electrons reaches in the microammeter, you can find the current develops. The reading of microammeter will be increases. That is nothing but photocurrent is producing there because of these electrons coming and contacting this anode terminal. This is the photocurrent production. Now here, what we are going to study here, that is the most important. This experimental effects. That is, First of all, the first important point is experimental effect. If I change these potentials, what type of output I will get? First thing. Okay? And for changing this potential, what I am doing now, here two parts are there. What are the two parts of photoelectric effect? The light which I am incidenting should have suitable frequency. That is one point that we will discuss later on. First of all, I am using the high intensify light. Means the light incidenting is having more intensity. Sir, intensity means what? We discuss in electromagnetic waves. More intensity in the sense, more number of electrons is emitting per unit area in unit time. More number of electrons emitting. I told you one thing. If you don't have suitable frequency, how much intensity you will not have photocurrent. You should have the suitable frequency. Above that only, if you incident a light with the more intensity, then you can expect the more photocurrent. That is the first effect. That you can see that how the experimental effect changes here. Look at here. Please be noted down this diagram because further whenever I am explaining the effects in each graph. This is anode. This is a cathode terminal. Here voltmeter is there as well as ammeter is there. Voltmeter shows potential, whether it is positive potential or negative potential, whatever it shows us. Okay. This is the external battery which creates the potential difference between those. Now, in this case, first effect is that whenever I am changing the intensity of incident light, when the frequency is constant, what happens to photocurrent is my question. If I am changing the intensity of incident light, what happens? Number of electrons will emit out more, right? Since more number of electrons comes, photocurrent will increase. Photocurrent will increase. But here, what is the constant? What is the constant? What I get constant? Photocurrent increases because of who? Involved in discussion. I have increased the photocurrent. How it is possible? It is possible because of increasing the intensity of incident light. Okay. Intensity of incident light if I increase, if your source of light, no, this intensity I have increased. Frequency is constant. No, it is independent with respect to intensity of incident and photocurrent all day when you are seeing the effects. If you finish, I'll move to the next slide, then you will see the graph with the condition. Then you will understand very clearly. Those graphs are most important. If you see old paper, 99% every paper you will find the photoelectric effect questions. Okay? So that's why it's a topic unavoidable for studying and easy and just theoretical. Yes. Okay? So that's why I'm stressing much on this topic. Hello, Dia. Please. Yeah, next. When a light of stable frequency falls on the metal cathode, photoelectrons are emitted. These photoelectrons are attracted towards the positive anode. Hence, photoelectric current is constituted in the circuit. Is it clear? Now, one after the other, we are going to discuss the effects, which is most important. I'm expecting everyone supposed to note down those effects also from this photoelectric effect. No. Please complete it. Shall I proceed next? First effect of intensity on incident, effect of intensity of incident light on photoelectric current. See, this is the intensity of light, this is the photocurrent. This is the intensity of light, this is the photocurrent. Now, if I am increasing the intensity of light, what happens? The photocurrent will be increases. Okay? This is when the frequency is constant. This is the first effect. You see the graph, you will find the linear graph, linearly is increasing. This is the first effect. They'll give the question, if intensity of incident light increases, what happens to the photoelectric current? And when it is, what is the condition? When the frequency is bent. Right? Next. That's what I said. For a fixed frequency, the photoelectric current increases linearly with increasing the intensity of incident light. The second effect of potential on photoelectric current. How battery potential will affect means there is a cathode and anode I have connected, right? In the diagram, previous diagram which we have seen. In that, right? In the diagram, previous diagram which we have seen. In that, I am changing the potential. How do you change the potential, sir? Battery terminals are there, no? From the battery terminals, I am increasing the positive potential. Means anode potential I am increasing, positive side. Okay? So, if I am increasing the anode potential, what happens? Usually, it adds number of electrons. Right? Potential difference will be increases. Then, if I will decrease the anode potential, what happens? Increasing it attracts, okay, fine. If it is decreases anode potential, positive potential I am decreasing in the sense, negative potential is increasing now, indirectly. You can see here, potential of anode in positive direction, I am increasing. Increasing now, indirectly. You can see here, potential of anode in positive direction, I am increasing. And current also will increase usually. Up to what extent it will increase? Up to certain extent only. Because here I am using constant frequency and intensity of light constant frequency and intensity of light if I change little more it increases. Okay, you can see here how it is. This is a L1, this is a L2. Means L1 is a frequency of light, L2 is also frequency of light. but L2 is greater than the L1. While I am increasing the anode potential, the intensity will increase. What it? Intensity will increase. So since intensity increases, photo current also increasing. No? Photo current has increased. But in negative direction, what I am doing, whatever I have increased the anode potential, I am decreasing now. Means, sir, why you are doing this all? This is nothing but what happens to the flow of electrons, how photoelectric current varies. That I am going to check. I am decreasing it in the sense it opposes the flow will increase, positivity rate will decrease. So negativity increases in the sense coming and trying to attract towards anode electrons. Whatever electrons coming and trying to attract towards anode, this is also becoming negative. Electron is also negative. Negative will reflect no, will repel back no. So electrons will not reach to the anode terminal. When you are increasing negative potential by decreasing the positive potential, where the photocurrent is zero, the potential point is called as stopping potential. What it is? Stopping potential. Most important term in the photoelectric effect. One is a threshold fix, another one is a mode function. Next, stopping potential. At what point photoelectric current is zero, that point of potential we call as stopping potential or else cutoff potential. What it is? Cutoff potential. In positive region, the current reaches the maximum. Okay, this is saturation current we call. More than that, it will not increase. Okay, here in this case, frequency is constant. Remember, in this effect. Now, one more effect I am going to show you. Whatever saturation potential that all given as a notes here. If you want, you can take up as a notes also. Yes, sir. You have written. Good. Yeah, please. Good. Yeah, please. Shall we discuss in the next class? In the evening time? Thank you, everyone.